the given region is bounded by the equations x is equal to 2 times square root of y, x is equal to 0, and y is equal to 9. For this equation, if I didn't give you the graph, it may be kind of hard to draw. But the way to do it is, you can divide by 2 on both sides, so we can look at this as x over 2 equals to square root of y, and we can square both sides, we can get the y by itself, and get x squared over 2 squared, which is 4. And we know x squared over 4, it's a parabola open up. But then we don't have the left-hand side, and the reason is because, look at the original equation, this is x equals to positive 2 times positive square root of y. The right-hand side is always going to be positive, right? So we only have the positive side. We don't have the left-hand side. However, this is just a graph, right? And x is equal to 0, it's the y-axis, and the equation y is equal to 9 is just the horizontal line. So this is the region that we are talking about. And what we want to do is, we'll take this region, rotate about the y-axis, and this is the solid that we are going to get. And we are going to find the volume of this solid. To do this, we can use the disk method. Okay, so just imagine you take out a CD, and what you want to do first is ask yourself, how are you going to place a CD to match the picture, either horizontally or vertically? As you have seen already, we are going to place the CD horizontally, just like the one I have drawn, right? And what you want to do from here is that by placing the CD horizontally, you need to determine how are you going to measure the thickness of the CD, either dy or dx. As you can see, the thickness is going to be the small change amount in the y-axis, right? The small y values. So the thickness is going to be measured by dy. You should always determine the thickness first, either dy or dx. But in this case, we know it's dy, so let me just put that down, and we can get ready. The volume is going to be, like, this is the idea of the disk method. Then we have the integral, and I can put a pi on the outside, so I'll have the pi on the outside and the integral. We know it's a dy situation, so we can look at the original graph right here, the 2D version of the graph. The y goes from 0 to 9, so the limit of the integration will be from 0 to 9. And you can see from the 3D picture, there's no gap, right? There's no missing part in the middle, so there's no subtraction needed. I can just open the parentheses, square that. All I need to worry about is to determine the radius, okay? Okay, so by looking at the red part I draw, the radius of the red part is going to be measured from the center, which is the x-axis, and that's the rotation axis. The radius is going from here to the curve. And this is the horizontal distance, so that's the x value. And I have to label this as x because the radius changes. Okay, the radius changes. However, since x is the radius, but I cannot really plug in x into the parentheses because x is not invited in the y world. I should look at the original equation, x is equal to 2 times square root of y. I'm going to enter this into the parentheses. So we have this right here as the integral that will calculate the volume for you by doing the disk method. And let me just go through this real quick. So the inside, we take 2 squared, we get the 4. Square root of y, square that, you get the y. Pi is still on the outside, and we still have the integral. This right here is 4y in the integral. We have to do the antiderivative. So let me do y to the first, and then we'll add 1, which is 2 altogether, and we'll have to divide it by 2. 4 divided by 2 is 2, and I can put the number on the outside, so I have the 2 pi right here. And the function part is just y squared, and that's the antiderivative part. I just have to plug in numbers now. The numbers are going from 0 to 9, and since 2 pi is just a number, you can leave it on the very outside. Plugging 9 into y, we have 9 squared, and then we subtract. Plugging 0 into y, we have 0 squared. So this part is gone. Look at this part. 9 squared is 81. 81 times 2 pi, that will give us 162 pi. And we are done. This is the answer for the volume of the solid. That's it.